Hello viewers, I am Kausalya. Today we are going to solve problem number 3 under the category Routh stability criteria. And the problem is construct Routh array and determine the stability of the system represented by the characteristic equation. Comment on the location of the roots of the characteristic equation. So here the characteristic equation is given. We have to check whether the system is stable or not. That is our first step. Then the next thing is finally we have to locate the roots. That is whether the roots are located on the right half of S plane or left half of S plane or on the imaginary axis we have to check. Right. So here comes the solution. So this is our characteristic equation. Right. So in this characteristic equation, for the first step is you have to check whether the powers are present in the descending order. That is all the powers are present or not. You see here 5, 4, 3, 2, 1 and here s to the power 0. So in this characteristic equation all the powers are present here. So the next step is we have to form our Routh array. So forming Routh array is easy, right? So here the maximum power is s to the power 5. So here I am starting with s to the power 5. So we have to write, since the power is odd, right? We have to write all the odd terms here. So coefficient of s to the power 5 is 1 and s cube is 2 and s to the power 1 is 3, right? So here I had written those terms. And the next thing is s to the power 4. So coefficient of s to the power 4 is 1 and coefficient of s square is 2 and coefficient of s to the power 0 is 5. So with the given characteristic equation, we had framed 2 rows of Routh array. And the remaining rows we have to solve and find out. Right. Now we are moving to our S3. So how to find here S3 row? As usual, you see 1 into 2 minus 2 into 1 divided by 1. Right? 1 into 2 minus this 2 into 1 divided by this corner element divided by 1. So here I had written this. So when you solve this, we are getting the answer as 0. That is 2 minus 2 which gives 0. So the first element is 0 here. Now we have to find the second element. For finding the second element, as usual, you can just hide this one. Just you can multiply. How to multiply? 1 into 3 minus 5 into 1 divided by this 1 again. Right. So 1 into 3 minus 5 into 1 by 1, which is 3 minus 5, which is equal to minus 2. So the second element is minus 2, right? So when you have the first element of a row as 0, you have to replace that 0 by epsilon here. Because when you proceed with this 0, anything divided by, here you see this is your corner element, right? When you multiply, you will be getting either 0 or infinity as answer. Okay, but a Routh array should not be like that. So we have to modify. So replace 0 by epsilon here and just proceed as usual. Epsilon into 2 minus of minus 2 into 1 divided by epsilon. Right. So here when you solve this 2 epsilon, here minus into minus becomes plus. So plus 2 divided by epsilon. So this is your first element of s to the power 2. So write the expression, right? Then how to find the second element? Here as usual, you can hide this one. That is epsilon into 5 minus, here there is no element, right, in this place. So I am taking it as 0. So epsilon into 5 minus 0 into 1 divided by this epsilon. You see here I have written the steps. So when you solve, the final answer is 5. So just write down the answer here, right? And the next step is we are going to find s to the power 1. So how to find this s to the power 1? The multiplication is as usual. You see 2 epsilon plus 2 by epsilon multiplied with this minus 2 minus of this 5 into epsilon and again divided by this term 2 epsilon plus 2 by epsilon, right? So you see here I had written the steps. This term multiplied with minus 2 and again minus of this 5 multiplied by this epsilon and divided by this corner element. Right. So the next step is we have to solve. You see this is a simple multiplication, right? So you have to multiply this minus 2 with these terms. So 2 epsilon into minus 2 gives you minus 4 epsilon, and 2 into minus 2 gives you minus 4 divided by this epsilon. Minus 5 into epsilon is 5 epsilon, and divided by this 2 epsilon plus 2 by epsilon, right? So the next step is we are taking LCM. You see this term has epsilon and here we are having simply 1. So when you take LCM, you see minus 4 epsilon minus 4, and this epsilon gets multiplied with this minus 5 epsilon. So finally here we will be getting minus 5 epsilon square divided by epsilon, and the whole term divided by this 2 epsilon plus 2 by epsilon, right? And the next thing, here I had rearranged the terms, that is epsilon square occupies the first place and epsilon the second place and constant in the third place. And since these three terms have minus sign, I am taking this minus sign commonly outside. So when you take this outside, what about the remaining things? 5 epsilon square plus 4 epsilon plus 4, right? The whole term divided by this epsilon into, I am moving this denominator to the numerator part. Whenever you move the denominator to the numerator, what happens? It will come as reciprocal. So here this is appearing as reciprocal. Epsilon divided by 2 epsilon plus 2, and this epsilon and epsilon cancels each other, and finally the remaining term is minus 5 epsilon square plus 4 epsilon plus 4 divided by 2 epsilon plus 2. So this is the term, right? So here I had written that term. And finally we have to find s to the power 0. So to find s to the power 0, again as usual, this term gets multiplied with 5, and here there is no second term, so here we can take it as 0. So 0 into 2 epsilon plus 2 by epsilon is 0. So this term is multiplied by 5 and again divided by, here the corner element is this term again. You see, I had written here. Right, this term gets multiplied by 5 minus 0 into 2 epsilon plus 2 by epsilon is 0. So divided by, okay, the whole term divided by, this is the corner element, so write the corner element as such. So here in this case, you see these two terms cancel each other and the remaining term is 5 here. So s to the power 0 is equal to 5, right? So here I had written 5. Right, finally we had formed our Routh array, right? Now we are moving to our next step. Now how to check whether the system is stable or not, because we are having an epsilon term here. So now we are making our epsilon term to 0. That is, we are substituting the value of epsilon as 0 so that we can tell whether the system is stable or unstable, and also we can comment on the location of roots also. So the next step is we are making epsilon equal to 0. So in the place of epsilon, we have to substitute 0 here. So when you substitute, you see, we are getting the answer like this. Right. 1, 1, 0, infinity, minus 2 and 5. You see, here I'll explain. So here epsilon is 0. You can substitute as 0. Here you see, here it becomes 0, right? 2 into 0 is 0. So 0 plus 2 divided by 0. So anything divided by 0 is infinity. So only here I had written the square term, the first term as infinity. And the next thing here in this expression, when you substitute epsilon as 0, what happens? 0, 0 and here minus 4. And again here 0 and here I will be having 2. Right, when I substitute epsilon as 0, I will be getting minus 4 by 2, which is nothing but minus 2. Right, so here I had written that. So finally our Routh array is formed here. Right, so from this Routh array we have to tell whether the system is stable or not. Right, so here when you look carefully, you see there is a sign change here. Right, so you can ask, what about infinity? Here infinity is what to say? This is the expression. From this expression you see 2 epsilon plus 2 by epsilon. So anything divided by epsilon is defined as infinity, right? So since this term doesn't contain any, that is what to say, any negative sign, right? We are taking that value as plus infinity, right? So only here I had written that term as plus infinity. So what are all the sign changes here? So from plus to minus, this is your first sign change, and from minus to plus is your second sign change. So totally how many sign changes? There are two sign changes, right? So how many roots are located on the right half of S plane? Two roots are located on the right half of the S plane, and remaining three roots are lying on the left half of the S plane, right? Hope you are clear with this, because the number of possible roots is 5. So among the 5 roots, since there are two sign changes, two roots are located on the on the right half of S plane, and therefore the remaining 3 roots will be lying on the left half, right? So whenever we have a sign change, whether the system will be stable or not, the system is completely unstable, right? So you have to finally come to the conclusion that the system is unstable, right? Hope you people understand the problem. Thank you.